Okay, up next we're going to talk about the factor theorem. So we're on cycle 10, day 5, slide 28. Today's warm-up is on slide 29. Wants us to factor again, so we're going to do that. This is just important tools for us to use later. So we're going to factor the first three terms, right? That's a general trinomial. Looking for factors of -3 that add to -2. We know that x squared comes by multiplying x and x. So we're going to have 3 and 1. We need a -2, so that's -3 and a +1. This next one is also a general trinomial, so we would be looking for factors of -10 that add to a +3. So to do that, looking for factors of -10, well, that's going to be 5 and 2. They need to have opposite signs, and they need to add to +3. So +5, -2, and then in order to get our x squared, we need x and x. Then it says, using the remainder theorem, determine the remainder for each, right? So it says divide this polynomial by x minus 3. So it's going to be important for us to remember what the k value is. Hopefully you remember that our k value should be, in this case, 3, right? Because the general form is x minus k. So our k value is going to be 3 here. So we're going to use the remainder theorem, which means we need to use synthetic substitution to figure out what the remainder is going to be all the way at the end. We have a degree of 3, 2, 1, 0, so we don't need any placeholders. So our coefficients are 2, 9, 14, and 5. We're going to drop down the 2. 3 times 2 is 6. 9 plus 6 is 15. 3 times 15 is going to be 45. 45 and 14 will be 59. 59 times 3, well, let's think about that, right? 3 times 50 is going to be 150. 3 times 9 would be 27, so that's going to be 177. Add that to 5, we'll have 182. So that is our remainder. So we found our answer for that one. If this was divided by x minus 3, our remainder would be 182. Next one. So we're going to find out our k value, right? Here, our k value is going to be, remember, our general form is x minus k, so we would have to write this as x minus a -2 in order for it to be in that general form. So our k value is -2. So we have -2 on the outside. Our coefficients are 3, -4, -28, -16. The degrees are 3, 2, 1, 0, so I don't need any placeholders. Drop down the 3. 3 times -2 is -6. Combine those, we get a -10. Times a -2 would give me a +20. -28 and a +20 would give me a -8. Multiply that by -2, we get a +16. -16 and 16 is 0. So our remainder here is 0. So hopefully what that signals to you that x plus 2 must be a factor of the function that we divided by, right? Because if something goes in evenly, that means it's a factor. So that's something that we're going to appreciate today because we're talking about the factor theorem. Moving on to slide 30, talking about the factor theorem, it says a polynomial f of x has a factor of x minus k if and only if f of k, so remember f of k, that's synthetic substitution we can use, right? So f of k is going to tell us the remainder, right? And remember, we can find out what f of k is by figuring out what this is at the very end. And we just talked about how if x minus k is a factor, then our remainder would have to be 0. So therefore, f of k has to be 0. So that's something helpful to know. It says this is useful in finding other factors and zeros / solutions. So it says factor x cubed minus 6x squared plus 5x plus 12 completely, given that x minus 4 is a factor. So we know this is a factor already. So what we're going to do is we're going to use that to help us break down what we have here. So it says to factor this completely, right? At this point, we can't factor this any further. This is not factorable at this stage. If we factored this by grouping, nothing would happen. So what we can do here, that actually might not be true. You might be able to factor this by grouping, but we have a hint here. So let's use the hint, okay? This is a hint. Normally, if you didn't have a hint, then you would try to factor this by grouping, which might be possible. But let's try to do this using what we're talking about here, which is called the factor theorem. So we know x minus 4 is a factor. So our k value, right? Remember, general form, x minus k. So then our k value has to equal 4. So that's going to go on the outside. And what goes on the inside, remember, are your coefficients. Just check that you don't need any placeholders. 3, 2, 1, 0. Nope. So we have 1, -6, 5, and 12. Drop down the 1. 4 times 1 is 4. -6 and 4 is -2. 4 times -2, -8. 5 and -8 is going to give us -3. 4 times -3 is -12. Oh, good, right? This is going to give us 0 as a remainder, which means we did our job correctly because we already knew that it was a factor. This is our remaining factor if we take out x minus 4, right? Because essentially we're taking this, dividing it by x minus 4. So our answer, when we divide it, is going to be part of our factor. So we have x minus 4 first. That gets multiplied whatever we have left. So first what we're going to do is we're going to write these 3 numbers, not the 0, that's just our remainder. So we're going to write 1, -2, -3. And this might help you understand that the last part's always going to be a constant. So that's our constant. Remember, our next number is going to have a variable of degree 1, so x to the first. And then our next number is going to go up by another degree, so x to the second power. So you might think, okay, well, what does that help us do in terms of factoring completely? Well, now this is something we can factor, right? This is something we can look at and factor because it's a general trinomial. So we're going to keep bringing down that x minus 4 that we factored out, right? And what we're left with, we're looking for factors of -3 that add to -2, so that's going to be -3 and +1. And now this polynomial is factored completely. So hopefully you understand what this is getting at. This is a hint. We factor out the x minus 4 by dividing this by x minus 4. So we need synthetic division to do that. We use synthetic division to divide x minus 4. So that means if you divide this by x minus 4, what you'll get is these numbers as your coefficients, x squared minus 2x minus 3, and then factor that if you can, and you're factored completely. Now we're going to use the factor theorem to find other zeros. So this is a different skill, but we're going to use the same kind of process. So it says find the other zeros of f of x, given that f of -2 is equal to 0. Well, this is your new hint, right? Not the same hint as the previous one, right? The previous hint gave you a factor. We don't know the factor quite yet because we were just told that f of -2 is going to be 0. This is an important key piece of information, right? Because we know that if f of k is equal to 0, right, then what must be true is that x minus k must be a factor. So it's essentially a step behind the last problem, right? We need to turn this into a factor that looks like this, right? So if our k value is going to be -2, that means our factor, right, our general form of x minus k, is going to be x minus -2. So we're going to simplify that to be x plus 2. So that's our factor. We're going to now use that information the same way we did in the previous problem, right? So our k value is going to be -2, remember, right? Our k value has to be -2. So that's the number we're going to write first, -2. Then we're going to write our coefficients, check for placeholders. So our degree is 3, 2, 1, 0. So we don't need any placeholders. 1, 2, -9, -18 are all of our coefficients. And then we use synthetic division. Remember, this is a factor, so it is going to hopefully give us a remainder of 0 if we did it correctly. 2 minus 2, 0. -2 times 0, 0. This gives us -9. -9 times -2 is a positive 18. Good. We got a remainder of 0. So remember, that's your remainder. We divided this, right? Essentially, we just did synthetic division. We divided this by x plus 2. So if we're factoring this out, then we can say that f of x is equal to, we factored out x plus 2, and now we'll get our remaining factor. So we're just going to write these numbers, 1, 0, -9. You don't have to write the 0, but it's going to be helpful with our next step. Remember, this is always going to be your constant, so no variable there. This has a degree of 1, so this is 0x. This has a degree of 2, so this is 1x squared. 0x. Do I need to write that? No, I don't need to write that. So f of x is equal to x plus 2 times x squared minus 9. So remember, our goal here, right, is to find the other zeros, right? If we know that -2 is a 0 already, right? We need to find the other zeros. We can already see there's our -2 as a 0. To find other zeros, we need to set this equal to 0 and factor completely. This, hopefully you remember, is the difference of squares. So this factors down to x plus 3, x minus 3. And then we can use the zero product property to find our remaining zeros, right? Here's that -2, right? That would make this factor 0, so that checks with the 0 that was given. And then we're given 2 more zeros, right? X equals -3, x equals positive 3. So our final answer, our 2 other zeros, is what the problem was asking for. So we combine everything that we've been doing to know what it means to divide polynomials, right? How we can use that in regards to factoring, and then using what we know about solving to find zeros, right? So just because the problem was looking for other zeros doesn't mean that this is not a 0. It's just I squared these because this is the answer that this problem was looking for. So essentially, our x values or our zeros are -2 and then positive or -3.